So I'm going to try and record this, obviously available on Zoom, but as well see if I can record it on my YouTube channel. All right, looks like it's working. Maybe a little bit delayed. And record this, obviously available on Zoom, but as well see if we can record it on my YouTube channel. Right,
if you go live on the YouTube channel, will that mean that we can later on rewatch the videos on YouTube?
Yeah, you should be able to watch it on YouTube as well. Although, how do I? Okay, I'm just gonna put this aside for a bit. All right, excellent. So the recording of these lectures should be available not only through Zoom, but it should also be available through my YouTube account, and I'll be sharing. I'll create a playlist so that all these will be available in one single playlist. My understanding is that even after we record this on Zoom, that you should be able to access those recordings right through the Canvas user interface. Let me know if you can't access it. I'm making sure not to password protect any of these recordings. So hopefully, we won't have to, I won't have to, you won't have to wait for me to post these videos. They'll be automatically available through the Zoom account. If they're not available, please let me know. And I'll need to work and configure it appropriately. But anyway, welcome everyone to CS3200 database design. I'm Jose Anunciado, and I will be your instructor for the next couple of months. We also have quite a few teaching assistants that will be helping out. We have about eight folks that have either taken this course or have before either with me or with other instructors, and they'll certainly be a great resource for you. Make sure that you take advantage of all the office hours that they're offering. We're trying to put them in quite a few different available times that should work out for all different time zones that you might be in. But if you see that there's no coverage for a particular time that you are available, that conflicts with other time from other courses, please let us know, and we will try to adapt and work for you. So if you go to Canvas, you should be able to see this screen here, where the first part of the modules at the top is going to be a module that contains several general hyperlinks that are available for all the different sections. We do have two sections that are covering more or less the same content, and I'm going to try and keep the two sections in sync. So if you find that it's more convenient for you to do it at another time, the other time is at 3:25. So if you feel that's more convenient to you, I don't really care which lecture you come to. Again, we're going to make sure that both sections are in sync. It's going to be the same assignments, the same material, and everything. Okay. Even though these lectures are going to be recorded, and you can consume this content at a later time, perhaps hopefully today. We are trying to discourage folks from binge watching these lectures. Okay, make sure that when a video, either you come to a lecture live, or if you're watching it shortly after, make sure that you watch the lecture as soon as possible, as opposed to postponing and watching 3, 4, 5 lectures all at once at a later date. I know it's challenging because you might have other classes and whatnot, but there's going to be time-sensitive information that I'm going to be sharing here in the lecture, and you're going to be responsible for those time-sensitive messages, right? I might say, hey, this Friday we're going to have a quiz, although that should be in your calendar, but nevertheless, there might be things that are time-sensitive that you're going to be responsible for anyway. Okay, so make sure that please watch the lectures as soon as they're made available. But other than that, you're not required to come to a lecture at the scheduled time, but you are strongly encouraged to take advantage of these time slots. So if you come here to this resources module, the syllabus is available here. We'll go over that in a minute. We have a link to Piazza. We will be using Piazza for all types of discussions, questions you might have. The TAs and myself are keeping an eye on on Piazza, not 24/7, but you know, I would say at least 16 hours a day, where somebody's watching your questions. If the person who's on watch doesn't know the answer right away, they'll make sure to let you know that they are on top of it. They're finding out, maybe asking others in the team, or asking myself. You know, there might be escalating it to me if there's some question that they might not know about. But certainly, I will make an effort to respond to you as soon as possible. Also, we have here the link to the lecture that should be able to get you in here. So if you're here, hopefully that link did work. Also, their office hours, obviously, they're going to be all remote. And so I have these office hours for myself at 7:30 p.m. on Tuesdays and Thursdays, although the TAs will be sharing their office hours with you at different times, which should be listed on the syllabus, which we'll go out in a minute. All right, so let's take if you click on the syllabus, it should take you here. And this is the syllabus for the course. Just you know, letting you know about the different times. Excuse me about that. There we go. Right. So these are the different meeting times that we're going to be getting together. We have 2 sections that are going to be sharing the same, you know, pretty much the same content throughout this semester. They're both on Tuesdays and Thursdays. The first one is the one where you're in right now, 1:35 to 3:15. That's Tuesdays and Fridays. And this is the same link that should get you, again, into the Zoom lectures, right? The one you're in right now. Again, if you prefer to come to the 3:25 lecture, that's fine. If you prefer to do that, it's available here. There will be quizzes that will occur during the time of the lecture. So make sure that the day of the quiz to come to the correct lecture that day. All right. Although, you know, we expect everybody to take the quiz at the same time during lecture. If for some reason there's some outstanding edge case where that's legitimate and reasonable, let me know, and we can schedule you perhaps to take it during section 4, right? Or if there's anything other reasonable reason, let me know, and we can work with you. To that, we might not make the answers to the quizzes available right away, because there might be other folks that have to take the quiz you know, soon after. So the answers to the quiz might not be available immediately. We might need to wait a day or two to make sure that everybody has taken those quizzes. This is down here is the instruction team. That's myself at the top over here. And this is a list of the office hours available. This is me, Tuesdays and Thursdays from 7:30 to 9 p.m. And this is the link to get into the office hours for myself. The TAs are adding their own office hours. So Kicho will be on Mondays and Wednesdays at 10 to noon, 10 to noon and 11 to noon. And that's his link. And we have Akshay, Sanjay, Nisara, Grace, Eduardo, and Ningyu, and Parth. They're all adding their links to their own specific Zooms. So make sure that to take advantage of these great folks and go to their office hours if you're stuck. You know, if you don't, you know, make sure that you know, if you feel that you're frustrated and something's not working, you know, stop and just ask. Okay, come to my office hours or one of the TAs. No reason to get frustrated. We're all here to help. You know, of course, it's much more challenging when we're not face to face, and it's so you know, everybody's a little more frustrated. Everybody is a little more antsy. So yeah, so we're all here to make this a success and make it enjoyable. Let's see. All right. So the goals of this course is to give you a chance to play around with relational databases, right? We're going to be using MySQL, MySQL to learn how to design databases, create databases, store data, retrieve data, optimize them, do transactions, how to interact with them programmatically using stored procedures, and also Java, the Java language to to interactly communicate with databases. We'll also explore some non-relational databases and some minor web development so that we can create some user interface with the database. There'll be about 10 assignments. This is the agenda for the course. Let's go over it briefly. Let's see. We're meeting twice a week, so Tuesdays and Fridays, and that's true, I believe, for most cases. Oh yeah. So there are no holidays or that impinge on our agenda, as opposed to my Monday classes. They have quite a few other holidays that impinge on the agenda. So, but not us. So we're Tuesdays and Fridays, so we're good. Tuesdays and Fridays. These are the basic general topics that we're going to be covering each week. This week is going to be mostly focused on making sure that we have an environment, a development environment up and running. We're going to be helping you install a database, create some really simple database connections. We'll create a schema, a database schema. We'll create a couple of tables, insert and retrieve data. A demo of more or less what you're going to be doing throughout the semester, right? The next couple of weeks, we're going to go into more details to the nitty-gritty on how is it that we design databases and implement them and query them and optimize them. Okay, but this week is making sure that everybody has at least a server running. We have a user interface, a client connecting to the database, and we have that all done. Installing software and setting up an environment can be somewhat painful. Especially because everybody has different operating systems. That we have different versions of that operating systems. We have different versions of the software we're installing, and folks might have older software installed that needs to be uninstalled. So please bear with us. It might be a little bumpy this week, making sure that everybody has the correct versions of everything. And we understand that it can be painful, but hopefully we can iron that out throughout this week. If we need a little more time to have the server up and running and the environment, we're certainly going to be lenient on some of these due dates, especially at the beginning, as folks are setting up everything and everything is ironed out. Okay. So these are the assignments for each week. This is DB1, which is installing the database. And that's going to be due next Tuesday, so a week from today. Right? So next Tuesday at midnight, right? Hopefully you'll all be done and you can submit your assignment. All assignments are submitted on Canvas, and we'll be asking you to submit some SQL script code or some database dump. And package it so that you can upload it into Canvas. So yeah, so the topics for this week, we're going to be definitely an introduction to the course. We're going to just go over installing MySQL Server and Workbench. We're going to create a simple database, and we're going to demo the things that you are going to be expected to do in the first assignment. We'll insert a couple of records, retrieve them, do some interactions, some lightweight interaction with the database. Okay. Next week, we'll spend some time talking about some of the theory behind designing a database. We're going to be spending most of our time talking about relational databases. But relational databases is just one particular way of creating a database, right? Using relationships, using records and foreign keys and primary keys and whatnot, right? All that jargon will become commonplace to you, right? But that's specific to relational databases. There are many other types of databases, in particular non-relational databases, right? There are real-time databases, hierarchical databases, XML databases. There's many types of databases. And so we're going to spend some time talking about, in general, theoretically, what is a database, right? How do you design a database, independently on how is it that you implement the database, on what particular technology you use to implement the database, right? In particular, the more common one and most popular way that most folks implement a database is through relational databases, right? Certainly has become the more common way of implementing, but there are many other different ways of implementing databases. So we want to talk about designing databases, right? In the abstract sense, right? What are the challenges of designing a database? The same challenges are going to be across any database vendor that you might choose, or any technology that you might choose to implement the database. So designing a database, in the abstract theoretical sense, right? For that, we're going to be using the Unified Modeling Language, UML, which we're going to be using class diagrams to define all the different data types and the relationships between the data types, and the general structure of the data that we want to store and retrieve and whatnot, right? So we'll talk about the theoretical framework behind that, and how we're going to be using UML throughout the entire course on talking about databases in the abstract sense, conceptually. And so there'll be an assignment for that. You'll be asked to design a database, right? Most of the assignments will ask you to, we'll demonstrate how to do something, right? And then we'll ask you to do it on your own, right? We'll say, here's how I do it, right? And then it says, well, now you try it, right? So we'll give you an example on how to do it, and then we'll ask you to try it on your own, right? So it'll bounce between those two ideas, right? So look at me do it, right? And now you try it on your own, right? So most of the assignments follow this pattern, right? Maybe not the first one, maybe not the first one, since we need a database to start off. Okay, so that's this week. The third week, once we've designed the database and we know what it is that we are storing, and whether it's the relationship between the different the data points and whatnot, we'll actually create the database, right? So we'll spend some time using the create statement, the SQL create statement, to create the tables and the various types of relationships of the different records on how they're related to one another. How do you create that? How do you impose certain restrictions, certain constraints on the database, right? So we'll spend a week on that. Once we have stored data in the database, we would like to be able to retrieve that data, right? We'd like to be able to retrieve that data using select statements. So we'll introduce the SQL select statement on retrieving a single record, working with a single table, and then working with multiple tables that are related to one another with foreign key, primary key, right? And we're going to join multiple tables into a result set, right? So we'll talk about quite a bit on that. On the fifth week, now that we know how to retrieve data, we can, we have the database. It has data. We can retrieve. We can read data from the database. We're going to talk about how to update that data, right? How to make sure we can change that data, right, over time, or remove the data, update the data, right, or insert and create new data, right? So we'll spend some time there. Around there on week 6, we're going to have at the end of February, we'll have our first exam. So that first class on Tuesday, we're going to have a review of the for the exam, and we'll go over the material up to that point, and then we'll have that exam during that Friday. Again, these exams are during class time. Okay, so that Friday, make sure that you come to the correct lecture, right? A couple of things that I missed. Starting on week 3 on Fridays, you're gonna have the first quiz, right? So that first quiz is gonna cover the material from the week before, right? So this quiz 1 will cover the material for designing databases. So quiz 2 is going to cover the material for creating databases. Creating databases. So quiz 3 is going to cover for the querying of databases, right? The inserting and updating, that's not going to be covered at any quiz. It'll be part of the first exam. Okay. Any questions so far? Yeah, please feel free to interrupt me anytime. All right, Ali is raising his hand. Let's see.
How long are the quizzes generally?
Oh, the quizzes shouldn't be more than 10, 15 minutes.
Okay.
Yeah, and they're timed. They're timed. They're all open book. So all the exams are open book. So you should feel familiarize yourselves with all the slides. Make sure you know where everything is. But during our review, we'll work together on all. We'll create a Google document which I'll share with everybody, which will have what were the types of questions that you should expect, things that are definitely going to be on the exam, which are things are not going to be in the exams. But certainly after the second week, you should expect one quiz every week, right? And always on Fridays. Except week 6 there'll be an exam instead of a quiz, and that exam will take the entire time of the lecture. All right, let's see. Yeah, so on week 7, we'll start talking about programming the database, right? We'll see how is it that we'll up to that point we will have covered the language, the SQL language that allows us to interact with the database, right? Being able to insert, delete, and using a language which is it's not a programming language, right? It's a declarative language, okay? And on week 7, we're going to introduce a programming language, right? That you can program right inside of the database, right? Where you'll have loops and if statements. You'll have functions that you can execute. Okay, Andrew, you raised your hand. What's up?
Yes, hi, Professor. You may have already gone over this, but I was wondering if you had a system where like the lowest quiz gets dropped.
I sometimes do that depending on how the performance of folks, how they're doing. And so, I mean, yes, we could totally consider that, but it'll depend more on how everyone's doing.
Got it. Thank you.
Yeah. Also, before I get further, notice that I have links to all these assignments. And even though I'm going to share links to the assignments, I would encourage you not to go too far ahead on the assignments. Because we are going to cover a lot of the material here in class, and I want to make sure that you don't run into some edge case or some trouble trying to work on assignments too far ahead. Those assignments are going to assume that you've covered certain material before that. Okay, so you can take a look at them and peruse through them on what's coming up. But I guess you can start playing around with them, but be warned that there might be some material there that has not yet been covered. And so yeah, I would advise to wait a little bit before you actually work on them. So the week 7 will start programming right inside of the database using programming stored procedures inside of the database. Week number 8, we're gonna introduce the fact that we can program outside of the database, right? Using any programming language, really. But in particular, we're going to be using Java, right? We could have chosen any other language. It could have been Python. It could have been C++, right? It could have been any programming language would do, right? So the language choice is as arbitrary as anything. I believe that you might have already seen some programming in other courses. Either you're currently learning about Java. Hopefully by week 7 or week 8, you will feel comfortable with Java. This is a little bit somewhat advanced, but we will provide you with everything you need to run and execute this code. Probably the assignment number 8 will be one of the more that are more handhold. We're going to handhold your hand more than any other assignments. Probably you'll need quite a bit of help. So yeah. Now, once we know how to program a little bit using Java and interact with the database, we'll spend a week talking about database-driven web applications, right? So we're gonna give you a really simple introduction to web development, and this is only to show you how folks outside that don't have direct access to the database, how would they interact or integrate with a database, right? They certainly need some kind of user interface. The user interface could have been any different types of user interfaces, right? It could have been just a command line interface, right? That's definitely an interface. I think that was a little bit too boring of having you implement a console-based interface with a database. But we want to be able to create an application, and applications obviously need some mechanism for users to interact with the application. And we could have chosen any number of user interfaces. We could have, Java certainly has a user interface mechanism that allows you to create desktop-based user interfaces. I thought that was a little bit too boring. We could have chosen mobile application. I think that's a little bit too advanced. So I settled on web. And the reason is not only because I enjoy it quite a bit, but it's typically one of the more common ways that you'll find in industry that folks will interact with the database, right? Folks will put together a simple HTML document that can quickly display records and will allow you to update those records, delete records, search for records. And so I want to give you a little bit on what all that world is like. If you've taken my web development course, this is going to be very trivial for you. But I'm not going to assume any prior knowledge on web development. So it's going to be very basic, enough for folks to do some considerable implementation on some simple user interface that you can use maybe for your project later on in the semester. Okay. Week 10, we're going to be talking about transactions and indexing on how to optimize databases. We'll see that obviously, you're going to mostly be working with a database where you're going to be the only one working with that database, right? You'll be the only user interacting with your database, right? Your database will be running locally on your machine, and you'll be the only one working, right? But in reality, when you go into industry, databases typically will be used by not just one user. It could be hundreds of users simultaneously. It could be thousands of users using that database simultaneously, right? So there's many different considerations that you have to have, on how is it that you design your database in such a way that it can support thousands of users using that same database at the same time, right? So we'll talk about that, and the way you deal with it is that you have to provide, the database needs to provide a mechanism to isolate one user from another user, so that if somebody is inserting a record and somebody's reading that record, that they're not trampling on each other, right? That there's a shared table or shared data point, right? That you have, if you have multiple users, right? You can have some inconsistency. All right, so we'll talk about transactions and how to deal with that. And that also that week, we'll talk about how to optimize the performance of databases, right? Because obviously we want to make sure that the more data you introduce into the database, that the performance is not degraded. And so there are many techniques to make sure that the database is always performant. So we'll talk about indexing and other techniques on how to make sure that the performance stays on par. Then on week 11, we'll talk about non-relational databases, and in particular, we'll talk about MongoDB and Firebase as two very popular technologies that provide non-relational database implementations. And these are a growing set of databases that are becoming more and more popular today, that it's definitely an alternative to relational databases that we're going to spend most of our time, I would say, 75% of the time, we're going to spend it on relational databases. Okay, but certainly there's a with the advent of of mobile computing and World Wide Web and applications moving to the web, there's there's a demand for unstructured data that folks are trying to every time you move your phone around, you're creating a huge stream of data that somebody is storing somewhere in a database, and they're trying to correlate your stream of data with another stream of data from somewhere else, and they're trying to match those streams and offer you something for sale, right? They're trying to sell you something, and so identifying what the structure of that unstructured data is, and for commercial purposes, is very important. So oftentimes the non-relational databases are used because you don't know the structure of the data a priori, right? Let's see. I think there's a post on the chat. When handling mass transactions, are we going to cover anything like sharding? Yeah, we'll talk about sharding as well. Yep, yeah, we will. We'll talk. MongoDB has some sharding and how to break up the database depending on geography and how it would be redundant in multiple places, and how it would be broken up in by zip code or by geography or by categories or by certain ways of how is it that you would break up a large database that way. The last 2 weeks, they're going to be focused towards the a final project. There is a final project due at the end of the semester, and even though these 2 weeks are put aside to get to work on the project, you're encouraged to start working on the project right away, even today. Get going on what is it that you might want to work. But these two weeks are put aside so that we can work together. We'll design a schema from scratch. I'll show you how to create a small user interface around that. Create different data models and data access objects and whatnot. And maybe we'll do some React front end for that. And if any help you might need, we can use the time, the lecture time to deal with those questions that are related to the project. There will be a couple of project related assignments where you'll be asked, show me what the design of the database is, and show me the create statements that will create your database. We'll ask you also what to create a data model and the beginnings of perhaps of a user interface, and how are you going to map that data model to an object data model mapped to a relational data model, and we'll talk about what that means. And the last lecture, right, where we're going to do the second exam, you'll have that week to finish off and implement the database. So those are 3 weeks that are geared towards that final project. But you're welcome to get started on the project, even now, right? Start thinking about what it is that you might want to do. The project is meant to be worked on together with other folks, with groups of 2, 3, up to 4 folks working in the same team. I think a good size team is either 2 or 3. I think 1 is too small. I think 4 is too big. Although you're welcome to go it alone and do the project on your own, or if you have some friends that you've worked with before and you're confident that you're going to work together very well, if you want to get together with teams of 4, that's fine. My experience has been that the bigger the team, the harder it is to coordinate everybody, and it's been very often the case that I've seen that big teams towards the end of the semester, there's always somebody who didn't do anything, or there's somebody who did all the work and says, oh, but I did all the work, but so and so didn't work as much. And I really want to leave that up to you. Okay, I'm just warning you that bigger teams are oftentimes more challenging to get everybody on the same page at the same time, and how to break up a project into smaller pieces so that everybody's working equitably, and then how to bring that together into a final project. So yeah, so there's a challenge. You've been warned. Hopefully towards the end of the semester, we can avoid things such as, oh, but professor, now so-and-so didn't work as much. I did everything, and I'm worried about my grade and blah, blah, blah. So yeah, make every effort, to deal with those things as early as possible. If something like that is happening, let me, bring it to my attention as early as you can, so that we can do something about it, okay? Anyway, week 14, I believe that is the last lecture on April 20th, Tuesday, April 20th. I believe the semester ends on the 21st. And so we're going to have the exam on Friday, April 23rd. Okay, that's I believe that's the first day of final exams, right? So we'll have that second exam there. And the project is due the week after, right? So you'll have another 3 days after the final exam to have the project due on April 26th. That gives the TAs and myself about a week to grade those final projects. And the grades are due on the 3rd of May. That's when the TAs and myself have to have grades in, and you should be able to see grades in my Northeastern on May 4th. Okay.
Excuse me, Professor.
Yes.
If we have a group in mind, should we just email you the names, or how would you like us going about
Right.
that?
So on Canvas, I'm going to open up multiple teams, and you'll join into those teams.
Cool. Thank you.
Yes.
Oh,
Yes.
I had another question. I have a friend who's in the other section of this class. She's in the 315 section. So is it possible to have people from the other section as well working with us?
So I'd rather not. I want to say yes, but certainly that puts burden on us to make sure that the grades are the same for both of you, right, on both sections. So I'd rather be just just a few folks. I don't want everybody to just let's everybody go and switch over to different sections and whatnot, and with everybody, right? Because Canvas doesn't support having grades across sections. So we'll just have to make sure that the grades that you get on one section is the same grade that other folks in the other section have, right? They'll be putting burden on us. But we'll say yes. But if I see a lot of people just doing this, and it's just going to it'll be an administration nightmare. So yeah, if it's one or two teams, that's fine. We can deal with that, right? But if it goes crazy, I think I'm going to pull back on that.
Okay, thank you.
All right, assignments. So assignments is going to be 40% of the grade. Quizzes, they're going to be about 8 quizzes. I hear notice that I'm saying about 10 about 10 assignments, about 8 quizzes. So I'm giving myself the option of skipping an assignment or skipping a quiz depending on how the semester is going. Okay, depending on we're going to throttle back and forth depending on how folks are doing, and if times slip a little bit or we're going too early, we'll adapt as we go. Okay. But certainly we're going to keep everybody up to date of what's going on. Please make sure to keep up to date on the Piazza posts and keep up to date on any messages we make, any announcements we make here in the lectures. If we are changing the dates a little bit. Okay. For the project, that's going to be 30% of your grade, and it's going to be you folks working together. Again, I think a good size team is either 2 or 3. I think those are two good sizes for the effort, for the amount of effort. 2 exams, which are 10% each, and these are the grades for F through A. The makeup policy. So the late policy is as follows. All these due dates are midnight. So this is Tuesday, January 26th by midnight. And if you need extra time, you don't need to ask for permission. Basically, what we'll do is that, if you need another hour or two or whatever, right? We'll just deduct 1 percentage point for every hour that you're late. Okay, so if you're late 3 hours, then the maximum you can get is 97. So we'll grade the full thing, and then we'll deduct how many hours you were late. Okay, so if you need 5 more hours to finish your assignment or whatever, then go ahead, right? Just submit it, and 5 hours late, and you'll know that you missed out on 5 points. You don't need to ask for permission or anything like that. Let's see what else. I think that's it. Make up assignments, GitHub account. We might use GitHub. How's everybody with GitHub? I'll ask a poll and see on how folks are doing with GitHub. If I see enough of you are feeling comfortable with using GitHub, we might use GitHub as a tool. Academic integrity. Please do not plagiarize. Make sure that if you don't look at anybody else's solution, or if you see solutions from previous semesters, please don't don't reuse. You can read it, you can try and understand what other folks might have done, that's fine, but don't blindly just copy and paste. Okay, the TAs are very good at finding these kinds of things, especially projects. If you see somebody else having done something in a previous semester and they have it on a GitHub and you have all the source code available, don't blindly just clone the repository or just blindly copy code. The TAs are very good at finding these things. Unfortunately, there's always 1 or 2 folks that didn't abide to this, and it's very awkward at the end of the semester, and a lot of folks crying, and that they have to report them, and it's very uncomfortable for me. It's uncomfortable for you. You might be graduating, and you might have family coming, and it's just going to be very awkward for everybody. So please do not do not copy, do not cheat. We obviously there's no way that I can enforce whether you're taking the quizzes on your own or not, but please make every effort to be as honest as you can in the course. I think that's it. Also, if you have a disability, if you have a special requirements, please notify me. I can schedule something for you. We'll work with you if you need more time on the exams. So certainly we'll accommodate you. So reach out to me in private, and we can work with you. Also, we are going to be using Piazza for most of our communication. Please stick to Piazza as your sole mechanism of communication. Please avoid using email. So this will help us all just have one mechanism of communication. If you need Piazza, you can send anonymous or you can send private messages, right? And it's just as useful as sending an email. But I get tons of email all the time, and it might be easy for me to miss an email that you might send me, as opposed to Piazza is curated. It is only relevant messages get to us. Also, we have 9 people looking at these messages all the time, so I think we'll be much better served if you use Piazza. Also, whenever you send a message on Piazza, please provide as much context as possible on what section you're in, what particular assignment you're having trouble with, and different things that you might have tried already. Maybe a screenshot. Help us help you. Right. The more relevant context you give us, the easier it will be for us to help you. Okay. All right, so it's Piazza. Any questions so far? All right, excellent. All right, so Canvas, let's see. Let's go back to Canvas. All right, so here, if you go down a little further, notice there's a Zoom meeting, which should let you into the Zoom meetings for this particular lecture, and will allow you to see all the scheduled meetings that we'll have. I believe it should also give you access to all the recordings that we've had on the lecture. I'm not quite sure. I mean, at least for on my end, it shows all the recordings from previous lectures. Please make sure that you do have access to those recordings, and let me know if you don't. All right. Ideally, I won't have to do anything to make the lectures available to you. That you'll have that already available, and without me doing anything. And I believe that's the way it works. But please reach out to me and let me know if you do not have access to those recordings. Also, Piazza, here's a link to the Piazza, to Piazza. You can either go this way, or you can click on this Piazza on the resources. All the assignments will be listed under assignments, and they're listed here. These are the 10 assignments, and then the 8 quizzes should be available here as well. If you go to quizzes, these are all the quizzes, right? All the 8 quizzes will be available through here. What else? People. If you go to people, I'm going to create project groups here. This is where you would join a group for the final project. I'm going to create about 20 groups, and you'll be able to join one of those groups. And the idea is that one of your teammates will join that group, a group, make sure that there's no one there, right? And then once they have once they've taken over that group, they can tell the other team members, hey, I've joined team number 13 or 14, right? And then all the other teammates can go ahead and join that group, right? Your grades are available through here for everybody. And what else? I think that's it. All right, let's take a look at the first assignment. Let's see, so if you go to assignments and you go to the first assignment, all the assignments are going to be available online through Google Docs, right? I believe I've copied here all links that are available to everybody. If you don't have access, please let me know and I'll open it up to everybody. So if you click on there, it should bring you to this first assignment. Can everybody see that? Anybody not see the first assignment? Okay. Yeah, so I'm assuming everybody can see this, and I can see 20 people are viewing this, 23. Oh, excellent. Looks like everybody has access. Right, so this first assignment is perhaps going to be one of the more bumpy assignments. So please bear with us. We're going to walk you through installing a relational database. Okay. Now these instructions are also available through slides. Right? So for instance, if you go back to the modules and you click on right here. Okay, so for instance, this hyperlink, if you click it, it takes you to where you can download MySQL Server. Right, so this is where you can download MySQL Server. It's also part of the instructions. Okay, but it's for your convenience, I've made it available here in the modules. Right, download the MySQL Community Server for free, and here I have slides that walk you through the process of installing MySQL and Workbench. Okay, so let's just look at this real quick. But this is a slide version, right, on the same steps that are described in the assignment. Okay, you'll need to install these 2 pieces of software. One is going to be the server, and the other one is going to be a client. Okay, and we'll talk about what that is in a minute. But by the end of this week, right, by next Tuesday, you need to have these 2 installed on your machine and working properly. Okay. So here's a diagram that explains what these two things are. So here's you, right, with a happy face. You're going to be interacting with, just a minute, high floating meeting controls. Okay. Yeah, so you're going to be interacting with Workbench, right? So this is the user interface that you're going to be spending most of your time, right? For the first half of this semester, spending most of your time working with Workbench. Okay, this is a user interface that is going to talk to a server, right? And so these are two halves of the same thing, right? So you're going to have the server running, which is going to be responsible for actually storing and retrieving data from the file system. So your data is going to live on some files, right, that are going to be stored in binary format, right, that only MySQL Server understands that format, right? So MySQL Server, you can install that. It's going to run. Typically, this server is going to be running all the time in the background, right, as a service, either in Mac OS or Windows. And you should be able to start it and stop either from the services panel in Windows, right, or from the system preferences on Mac, right? And this runs all the time, right? And this is going to be listening at a port, right? It's going to be listening for incoming HTTP, network requests at port 3306, right? That's a common standard port that it's listening, right? And the way you're going to connect to it is with a client application, right? Now, the one we're going to be covering in this class, right, is the MySQL Workbench, right? It's referred to as a database client, right? And this is the one that we're going to be using most of the time. Well, actually, no, in this course, this is the only one we're going to be using, right? But there's tons of these clients out there, right? There's alternative clients. If you prefer using other clients, that's fine. It's you don't have to use MySQL Workbench, but there's there's DataGrib, there's Toad, there's a lot of other vendors that provide their SQLite on Mac. There's many different vendors that can connect to MySQL Server. Okay, if you feel comfortable using those other clients, then by all means use them, right? But if you we're going to be covering in detail, right, how to use MySQL Workbench, all the assignments, right? All the instructions that you will find in this class are based assuming that you are using MySQL Workbench. Okay. So if you're using other clients, you're kind of on your own. All right. Okay. Yeah. So this is kind of like the topology of what we're going to be working on during the semester, right? So on Windows, so these are the instructions on how to install MySQL Workbench and MySQL Server on Windows, right? So they ask you to navigate to that URL I showed you earlier. It asks you to create an account with them in Oracle. Oracle is the owner of MySQL. You don't have to. You can just skip this, and it will download an MSI on Windows, which you can run it, right? And then you can install some custom installations, right? You can go to the default, or you can do the custom installation. In the custom installation, it allows you to select that you want MySQL Server, right? You can add it onto the right-hand side. You can then add Workbench, and then you can do next, right? It'll download all the software. Here there was something else I didn't want to show. And you can execute this, and it'll install. During the install, it's going to ask you, how do you want to install it? Standalone is fine. Standalone meaning that this server is going to be running on its own on your machine, right? And as opposed to you could put it inside of a cluster, right? In real life, in industry, you would typically not have just one database, but you'll have a multiple database working together, right, to be able to help it work better with the workload, right? If you have thousands of people, hitting the database, you want to make sure that if one database is too busy, another database can pick it up. So we're not going to do that, right? We're not going to run clusters or anything like that. Everybody's going to have their own database running on their own machine, right? But typically these databases would not be running on your machine, right? And usually it'll be running on some remote server, right? But we're going to keep it simple, is just your database running locally on your machine. This, you can, for the type of networking configuration, you can leave the default, right? By default it listens at port 3306. That's common. You can leave it TCP/IP. So you can leave that alone. Authentication, recommended is that you use strong password encryption, and you'll be asked for a password for the root account. Okay, so this root account is the default account that is available out of the box when you install MySQL Server. Okay, this password is very important. Don't forget this password. Okay, if you forget this password, you're going to have to reinstall the whole thing all over again. So it's going to be very painful. So don't forget the password. Okay, so this is the root password. The username is root, and the password is whatever you type here. Okay, so make sure to write down your password somewhere. I believe in the assignment I ask you to use a standard password, so that if ever you forget the password, we know that, oh, there it is. Yeah, I'm asking you to use this password, right? Capital P at SSW0RD. And this is so that everybody has the same password, so that there's no way that anybody's going to forget it, right? And it doesn't really matter, since this is your database running on your machine. Nobody's going to use it anyway, right? Because somebody would have to be able to log it into your database, into your machine, right? Anyway, then you're going to start the server, and you're going to configure it so that the server automatically starts at the beginning when your machine boots up, right? So that your server is always up and running, right? It's always listening at port 3306, waiting for a client to connect to your database, right? And obviously it'll shut down when you shut down the machine. Okay, so configure that. If you configure that way, eventually you'll be able to see the SQL Server running as a service. Okay, if you go to the services on Windows, right, you'll be able to scroll down and find MySQL there, and you'll have you can either right click on it and manipulate it and work with it, or you can stop and start it from this UI, from the services panel. Okay, so that's on Windows. Now on Mac OS, slightly different, same exact idea, but the user interface is slightly different, right? You can download it from the same page as you can from Windows, but you select Mac OS instead. And when you download it, you download a DMG. Same thing, asks you if you want to create an account. You can skip that, no thanks. It'll download to your downloads folder. It'll be a DMG file. You can double click on that. It'll unzip, and you'll have a package, a PKG in there that you can run. If you double click on that, it'll start the installation process, right? It'll warn you saying, hey, this is not an app that you downloaded from the App Store, right? And indeed you didn't, right? You didn't install it from the App Store. So it's going to ask you, are you sure you want to run this, right? You didn't download this from the App Store. You're going to have to go into the system preferences, into the security and privacy, right? If you go in there, right, in there you can say, yes, please let this application run. You can say, it'll say, your MySQL PKG, try to open. Are you sure? And you say, yeah, open anyway. Just let it go through. Okay. It'll run the installer, and once again, it'll ask you, are you sure? It might even ask you to log in and provide your credentials, your username and password for your laptop or your machine. Right? Provide your username and password to allow it to run. So once it starts installing, you ask it to install for anybody who's logged into your machine. Right? So install for all users. Again, it might ask you to provide credentials to make changes to the local system. Provide your username and password, and then run the installation. right? So let the installation go through the whole thing. It'll write a whole bunch of files to your local system. Just like we did for Windows, configure a strong password encryption, and we'll ask you for the password for the root account, right? So again, same thing like in Windows, right? It creates a default root user, and please provide a password. Again, do not forget this password. If you forget this password, you're gonna have to reinstall the whole thing again, right? It'll be painful. So jot down the password somewhere, and or use the password that we suggest in the assignment. It'll be successful. Once it's done, you'll have a new icon in the system preferences. Right, so if you go to system preferences, you'll have at the bottom there'll be a MySQL icon now, right? That if you click on it, right, you'll be given this this configuration panel now where you can start and stop the server, right? The MySQL server right here, or you can configure it so that it automatically starts up when the system, when your machine starts up automatically. Okay. Anyway, so those are the steps, the first couple of steps in the assignment, right? In the assignment, if you go through the assignment, I walk you through the same process we just went over, right? Where we ask you to download the database from here, right? Either from Mac or Windows is the same thing. But if you're on a Windows, here are the steps, right? Go and select Windows, download the installer, say no thanks, right? Run it. User account control, it might ask you, are you sure you want to run this? Right, so these go into detail, the steps that you should follow to install your database. Okay, so first I presented for Windows. I also walk you through configuring the the server as standalone, right? Strong password encryption. I suggest you use this password. Everybody use the same password for root, so that if the TA needs to help you and he needs to, in office hours needs to log in and do something, he already knows what the password is. Now there's a video that you can follow along, where that walks you through this process. On Mac OS, here are the instructions, right? Downloading the DMG file, double-clicking in and unzipping the package, right? Accepting the license, installing, then configuring a password for the root user. Again, I ask you to use that same password as earlier, password. Okay, close for when it's successful, and in system preferences, right? You'll have a new MySQL icon that you can start and stop, right? And you can configure so that MySQL starts when your computer starts, right? It also walks you through downloading and installing Workbench. Okay. All right. Any questions so far? All right. All right. So the next thing that the assignment asks you to do is that when you start Workbench, Workbench is going to open up. Let's start up Workbench. I'll start Workbench. Do I have Workbench up and running? Let me see. Wait. I'm going to run Workbench. Okay, so here's Workbench. So here you're going to create a connection. So right now, this Workbench is not talking to the database, not just yet, right? So you have the database running in the background, right? We call that the server. And this application we call the client, right? This is just provides a user interface to talk to that SQL server. There's another interface. There's a command line interface, right? That you can also use, right? You can use the command line interface, but we're not going to cover that here. We're going to mostly use the client. So we need to connect the client application, this user interface. We have to connect it to the server, the database server. And the way we do that is that we create a brand new connection. Okay. Now here I've created already a connection. I've created a whole bunch of connections. And the way that you create it is with this plus here. See that? This small little tiny plus sign here. You click on that, you can create a brand new connection. You can call the connection whatever you want, doesn't matter, right? As long as it's a unique name. It defaults to the local machine. Notice that it's 127.0.0.1. That IP address, right, is points or refers to the local machine that you're currently using. All right, so 127.0.0.1 is a standard IP address, right, that always references the local machine. The port, that's the default port, that's perfect, 3306, so leave that alone. 27.0.0.1, that's also leave it alone. Here's your root username. Okay, that's the same username that you just created the password for, right? You can test connection. If you haven't logged in yet, right? If this is the very first time, it's going to ask you for a password. Okay. If you are already logged in right before with root, it's not going to ask you for a password. It's going to store it on a Mac. It stores it in a keychain. Right. It remembers the passwords for that user. Right. Now we can create it here. We're going to call it DB connection. I'm going to put a lecture next to it so that we know that this is in the assignment. I believe I asked you to create the connection and call it DB connection. See that? I asked you to do DB connection. And I walk you through the screenshots here on how to do it. Right? You can test the connection. You can say, well, does that work? And it should say successful. You know, I'm able to ping the server. The server is listening, right? And then I can say okay. The okay will actually create the connection, right? And then we'll add it. We'll just add it here as a brand new connection, right? So I can say I'm not going to create it. Right? You already have a connection. It will appear here as in your grid, so that next time around, next day you come back, you can just create the connection, and you don't need to recreate it. You can just use one that is already there. So once you click on it, you'll go into the main screen, right? That is interacting with the database, right? Okay, so on the left-hand side, you have a list of what are called schemas. Okay, schemas. So a schema, right, is a collection of tables, right? And a table is a collection of records, okay? And a record is a collection of fields. So let's talk about this again. So schemas are basically oftentimes folks use database and schema interchangeably, right? Sometimes they'll use schema when they really mean a database, and sometimes we'll use a database when you really mean a schema. But schema in general is the structure of the data, right? So a schema in general terms, conceptually, schema means the structure of the data that you're working with, right? So if I say here, I have here multiple schemas, it's the same thing as saying, well, I have multiple data structures, okay? So we're going to create a schema specific for this course, right? And we're going to call it. Everybody's going to call it the same. Again, this is going to simplify the TAs and myself, right? If everybody follows the same naming convention, everybody names it the same way, right? It'll make it so much easier for everybody, right? We're going to create a schema called DB_design, right? Database design. Okay. And notice that it's bold. See that? It's bold, but all the other ones are not bold, right? And the way it becomes bold is that you double click on it. If you double click on it, it becomes bold, and it means that this is the default schema. It's the schema that you're going to be working with from now on, right? If you double click any other schema, then it becomes the default schema, right? So A2 now is the default schema, or if I double click on airline, that's the default schema that I'm working with, right? So if I double click on DB design, that's the schema that I'm going to be working with. So how do I create a schema? How do I create it? So to create a new schema, here you have on the top here, you have this toolbar over here. See that? See this cylindrical thing here, right? It's a database icon. See that? So that's why oftentimes folks refer to it as a database, right? So it's the DB design database, right? This is the airline database, and this is the experiments database, the injection database, the lectures database, right? Again, oftentimes you'll hear me say databases when I really mean schemas, right? Folks use those terms interchangeably, right? So here I have many databases, right? But it's schemas is the formal name for these things. Okay. All right. So how do I create a database? I'm sorry, a schema. We click here on this cylinder here. We click on it, and it opens up a new schema window. Right. We have this new schema window, and here you can create a brand new schema, brand new database. Right. So let's create one. We say DB_design. I'm going to put lecture. I'm going to put a lecture on it, right? So I can distinguish it from the one that I already have. Okay. And we create apply. We create apply. You'll notice, right? This is the statement that creates the schema. Right. This is, again, there's a user interface. There's a console version of the SQL client of the MySQL client that you type all these commands at the command line, as opposed to using a user interface, right? And this was what you would actually type. Okay, so what the Workbench user interface does is just gives you a user interface, right? It gives you the buttons that you click, blah 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 blah, and it creates the statements that would actually create and do the things in the database. So this is the command that the client is going to send over to the server. Say, hey server, create a brand new schema, right? And the server will create all the files, the binary files and directories and more, right, for creating that schema. So I'm going to click on apply, and it's going to say, yeah, that was successful. It was successful. I created a brand new schema. And you should see it here. There it is. See that? DB design lecture. See that? Notice it's not the default. I need to double click it to make it the default. Okay. I'm going to just close everything else here. Close everything else. Okay, so there it is. So that's the command that we use to create it. I can now just close it. I don't need it anymore. The schema has been created. I can double click it, and it's now the default schema, meaning all subsequent commands that I make are going to go against that schema, right? Any new data that I insert is going to go into that schema. Okay, everybody okay? Everybody still with me? Anyway, so the create a database schema walks you through doing that. Right, walks you, it hands holds you on how to do this. Right, create schema, yada yada yada. There it is. Right. It also walks you through asking you to create create a table. Right, creating your first table. Also notice that it reminds you, double click the schema to make it the default schema, right? So don't forget to make it the default schema. So let me demonstrate on how you would create a brand new table. So what a table is, so a table is what it sounds, right? It's something you might maybe find if you're using Excel, like an Excel spreadsheet, right? Or Google Sheets, right? Where you have a whole bunch of rows, right? You have a whole bunch of columns, and so a table is a conceptual way of thinking on how to structure data, right? Folks, if you look at the spreadsheet, each row presumably, right, has data points of all the data in one row, presumably in an Excel spreadsheet, right, is related to a single instance of something, right? If you look at a table of anything, right, of a table describing employees or describing products or describing anything, right? The way you might think about it in an Excel spreadsheet is that each column, right, describes the different fields that you are storing about a particular data point, right? So say this is a product, then the things that you want to capture of a product might be, you know, the SKU, the price, the quantity, a description, right? A name, things like that, right? So those are the fields, right? So each product has that many fields, right? And we say that the schema or the structure of the data of that field, of that data point has all those fields, right? And then you might have one line, each row represents a product, and you can have any number of rows representing many products. So that's the way we want to conceptually think about the data, and that's how we're going to talk about it for the next couple months on how data is structured. Obviously, in reality, these tables don't actually exist, right? This is all conceptual. In a file system, these are all zeros and ones, right? And tables are just a conceptual way of thinking about the data. Anyway, so let's create a table. There are two ways of creating a table. You can either right-click and say Create Table, or right, if you have the lectures selector, the schema selected, you can say right here, this plus sign over here. See that? Just create a new table. You can do it either way, right? So either way, you can. I'm going to do it this way. I'm going to create table. Excuse me. Oh, sorry, table. Say create table, and this opens up the new table user interface, right? And excuse me. So here you can create a table. We're going to ask you to create a table called users. Okay, users. Okay, and again, you can use it. You can create it both ways, right? You can right click and do a create table, or you can click on this plus over here. And if you right click on the tables and say create table, right, you can then type in the name of the table. Okay. I'm not going to create the users table for you. I'm going to demonstrate. I'm going to create a completely different table. Okay, I'm going to call it, maybe I'm going to create a courses table. Okay, these might be the courses that you might be taking in a semester, right, or throughout a career, right? And notice the naming convention. The naming convention is that it's a noun, right? It's plural. See that? And also right now it's just one word, right? Right now it's just one noun. If this were a compound word where you have where there's two words, then you would use an underscore in between. Okay. Also, the columns here, these are the different fields that make up the records here, right? So one of the fields I'm going to ask you to always be ID. ID. Okay. Not course ID. Right, not anything other, just ID. So let's standardize that, right? This is going to make it just simple for the TAs and myself to grade your assignments. It's going to make it easier. Although you're not forced to for the field to be called ID. It's just going to make it simpler for everybody if we standardize the ID. So this ID is going to be useful for uniquely identifying a record, right? A particular course, right? And we're going to notice that here we're going to select it, and this is going to be the primary key, meaning this is the unique identifier that identifies this particular instance. It's like your student ID, right? Your student or your social security, right? That's a unique identifier that identifies you in a particular context, right? Your student ID identifies you as unique within the context of the university, right? A social security identifies you uniquely within the IRS, right? Internal Revenue Service. Okay, so that's the primary key. It's not null, meaning you have to give me a value for that. We're not going to select unique. Your primary keys already are unique. And we're going to also select AI. AI meaning auto increment, right? Meaning the values for this field are going to automatically be created by the database. Another field that I want to create here, maybe it's a title, or maybe the name of the course. And by default, it's saying that it's varchar. Varchar means that this is a string, and the size is 45 characters. What else what might we do? Yeah, let's leave it at that. Let's just keep it that. Yeah, so there it is. So we have 2 fields, and here when you click apply, right, it comes up with the command, with the create command that is going to be sent over to the server, so that the server actually creates this table. And notice the way it creates it is that it says in the schema, right, create this table that has these 2 fields, right? One of them is an integer. It's not null, it's auto increment, right? And it's a primary key. This ID is a primary key. We're going to learn about this a little later. We're going to spend more time talking about this command and how it works and whatnot. But I think it's understandable what's going on, right? It's creating this table. Also, another field called name that I'd say it's kind of like a string. It can be null, right? It is okay if you don't provide values. You definitely need to provide value for ID. I'm going to say apply. So it gets applied and says, yeah, executed successful. I'm going to say close that. And down below here, you could see if there are any errors, right? It's kind of a log of what you've been doing so far, and if been successful or not and whatnot, right? Or it can give you a clue on what, if anything went wrong, it would tell you what's going on down here. Notice that if I open up tables, notice that courses is there now, which was not there before, right? And if you open it up, you can see the columns, right? See the ID and the name, right? So perfect, excellent. What else? Yeah, so this asks you to do the same thing, but with the users table, right? One note here, notice that the field names, notice that they, the field names here have an underscore. See that the underscore right here? That's because these field names, first name is a compound word, right? First name. And so what we're going to do, the naming convention that we're going to follow, right, is that tables, right, are nouns. They're plural. The convention is that they're going to be all lowercase. Also, the fields are also going to be all lowercase. Okay. And if you have 2 words, we're going to put an underscore in between so that it makes it easier to read, right? First name, right? It's harder if you don't have a delimiter, okay? We could have done this, capitalize. We could have done it using camel case. This is called camel casing, right? But this is okay if you're using a language such as Java or JavaScript or Python, languages that are case sensitive, but SQL is not case sensitive, right? So this, capitalize or lowercase or mixture of casing, SQL doesn't care, right? So the way we're going to do this is that we're going to standardize, and we're just going to use underscore to separate compound words. Okay. All right. What else? Users. All right. So let's insert now data into our brand new table. To insert data, it's very easy. We're going to do courses. Notice that here there's an icon here. See that? If you click on the table, if you click on that icon, it does a select. See this select over here? This select. We'll talk about this select a little later. But basically, just as a preview, what it does is that it's retrieving the current data in the database from this schema, from this table. The reason it knows that it's this schema, it's because it's the default schema, right? Because I double clicked it, it knows, right? And then it's because I clicked on this here, it knows it's the courses table. Notice that it says there's no data. Notice that the result grid appears down below, that it shows you the current data. Okay. Well, here we can now enter new data, right? We can right here in the user interface, and we can type some courses, right? So I'm teaching CS3200, and I'm also teaching CS5610, and I'm teaching CS4550 and whatnot. So these are some of the courses that I teach. Notice that I'm not putting values for the ID, And that's deliberate because, I mean, I could put a values for there, but I don't have to because that field was configured to be auto incremented, right? And it will start at 1 and then automatically go to 2 and 3 and 4 automatically, okay? Also notice that once I type something, right, if I type something, if I don't type enter, okay, it's not going to actually add the data, okay? So be careful. If you want to make sure that you did insert data, make sure that you type enter or return, okay? All right, the data is not yet in the database, not yet, not quite yet. Only when you click on the apply button does it actually insert it, right? So I don't want this. So delete rows. I'll remove that. So when you click on apply, basically it's going to write for you the SQL insert statements that will insert this data in the database. These are the commands that is going to be sent over to the server, right, for execution. And it says that I'm going to insert into the courses table in this schema. For this field, I want this value. For this field, I want this value. For this field, I want this value, right? And again, we'll spend some more time, a whole week on the insert, the update, the delete statements, right? So if you're overwhelmed by this, don't worry, right? We'll revisit this with much care a little later, around I think third or fourth week, okay? But meanwhile, we're gonna apply. For now, in this first assignment, we're going to walk you through all this. We're going to handhold you all the way through, right? Because we know you haven't used the create statement yet ever. Well, some of you might have, right? We haven't used the select statement. You haven't used the insert statement. So this might be overwhelming for you at first, but don't worry, right? We're going to handhold you throughout. We're going to apply. It's going to say, yeah, successful. I'm going to close that. Right. Notice that now the records, right, we have the IDs 1, 2, and 3. See that we didn't create it. They were auto incremented. Yes. All right. So that's the. I asked you to do the same thing, but for adding a couple of users into the user table, I'm asking you to insert Alice Wonderland, Bob Hope, first and last name, and verify that you have those insert statements. You can now that we have inserted data into the database, you can now retrieve that data, right? So for instance, let me close that. And, if you close all this and you come back tomorrow, right, you can go to that table, the courses table, and you can click on the data grid, right? And it executes the query and it retrieves it. See that? Okay, so that is the data is still there. So I'm going to ask you as part of the assignments, right? I'm going to ask you as part of the assignment to copy these statements that you've been working on. Okay. Well, not on the inserts, not on the create, but these statements of retrieving data, like retrieving all records, like we just did here. You're going to copy this and you're going to save it into a file. And the way you save to a file is you can click here on this save button, or you can do file save, right? Save script, right? You can say save, right? And we're asking you to save it and as this, select all SQL. See that? Select all users. So this would be select all courses. Select all courses. Okay. And we're gonna maybe do it under Janunzi, and we'll go NEU, excuse me, 2021, spring 3200, and this is for the first assignment. So maybe this is DB1. In DB1, I'll save it as select all courses. Save. Okay. Then I'll ask you to retrieve records using some criteria. For instance, here we're asking you, retrieve all the users whose first name is Alice. Okay. In my case, we could do something a little more interesting. You can open up a new script by clicking here on the SQL icon. See that? If I click on there, it opens up a brand new SQL. And here I can type queries. Right here, they're asking you to do select star from users where users first name is Alice. That retrieves all the users whose first name is Alice. In our case, there's only one user with Alice. Let's do something similar here. We're going to say select, I can't type today, select star from courses where title equal CS3200. Okay, like that. Okay, so we can execute it by either clicking on this lightning rod, right? And that didn't work. Wait, what? Oh, did I not? Oh, it's not title, it's name. Sorry. Notice it gave me an error here. See that? Gave me an error. So make sure that if it doesn't do what you expect to read, look for any errors down below here, and it'll give you a clue on what went wrong. Let's try that again. We can click on the lightning bolt, and there it is. See that? It retrieved one record, right? Indeed, there's only one record with the name CS3200. Let's save this. I'm going to save this. Wait, cancel, save. So I think this is what? This is, I'm going to call it select users by first name. So this is, I'm going to call it select courses by name. Okay, perfect. And finally, we're asking you to retrieve a record by using its primary key. Okay, so we know, right, from the all courses that if we know the ID, we should be able to retrieve that one record. Okay, so let's retrieve the one with record ID equal 3. So let's do that. Let's open up a new SQL, and let's do that, right? Let's use the primary key. So we'll do select star. Star means everything. Retrieve all the fields. Right, so select star from courses where the ID is equal to 3. And we'll always add a semicolon at the end, right? And we run the lightning bolt. Or if you select the row, you can also do command or control return or enter, and then it executes it, right? So you can do the keyboard or you can do the lightning rod. And there it is. There's our record, right? CS4550. See that? So here we're going to save this one too. We say select courses by primary key. Save that. Okay, well, I'll ask you to select users by ID, right? And finally, we're going to ask you to, these 3 files, you're going to upload them to Canvas, but also we're going to ask you to export the whole database, right? You can export the database. If you go to server, there's data export. See that? We'll ask you to export the entire database and submit it in Canvas. So you can say data export. And you can select the schema that you want to export, right? You can select, this is the schema that I want to export. If you have more than one table, they will be listed here. Here we only have the courses table. And then you can also say where to store the data dump, right? So it's going to dump all the data in that schema into that directory. Okay, so I'm going to say export there, and what it's going to do is going to create files for each one of the tables, right? In this case, we only have one table, so it's going to create courses.sql, right, as a dump. So I'm going to say start export. There might be a type mismatch. I'm just going to go continue anyway, and it's done. So if we go to that directory, this would be Janunzi. And this should be in data something or dump maybe. There it is, dumps. See that? Where'd it go? There we go. So we go to dumps. The very latest one for today is which one? Let's see. 13 must be this one. There we go. See that? If we open it up, there's the SQL we just created. See that? It's by default, the naming convention is that it shows the name of the schema and then the table. If you have more than one table, it would be listed here. If you double click on it, you can see that this is all you would need to recreate your database, right? I can TAs can take this SQL file, okay, and they can import your database, okay. Notice that it shows all the commands that would require for somebody to recreate your database. See that? For instance, this command drops the table if it already exists, and then it recreates the table from scratch. There it is. See that? ID and the name and whatnot, the primary key, and then it inserts the original data that was in that table. There they are, the three records I had there with the original IDs and everything. See that? And then it's done. So the TAs can recreate your database by importing this file, right, and see your work. All right. So again, for the assignment, we ask you to submit those 3 things. We ask you to submit the 3 SQL files for selecting and the dump, right, the data dump for the users table. In this case, we demonstrated for the courses. Okay. All right. Yeah, there you go. So we demonstrated the first assignment. Again, I think once you install the database and you have workbench running and the server running, I think the server this assignment will walk you through making sure that everything is working correctly, and hopefully it'll be easy to complete. The bumpy part will be making sure that it actually runs, right? And I think most of you, I think 90-95% of you won't have an issue, but certainly there will be some edge cases, maybe 5% of you because you either had a previous version or the version doesn't work on your operating system, and that's where the TAs and myself are going to be available to help those of you who are having issues. Okay. All right, I'm going to leave it here. I do have an office hours later tonight at 7:30. If you want to join, we can do several one-on-ones and help you out. Please come by at 7:30 and we can help you out. Okay. All right, folks. I do need to jump on another class, the next section. Of CS3200, and to get ready for that. Any questions before we're done? If you're talking, I don't know if I can't hear you. You might need to unmute.
Thank you, Professor.
All right, thank you, everyone. See you
Thank you,
Friday.
Professor.
Cheers. Bye-bye.
Have a nice rest of your day.
Thank you.
You too. Bye-bye.
Hi, Professor. I still had one more question.
What's up?
I was just wondering, because you did say like group of 3 is ideal, and are you completely against the idea of 4?
Oh no, absolutely not. If you feel that you
Oh.
can manage the complexity of 4 folks and run the risk of at the end folks not having done blah 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 and coordinating everyone, by all
Right.
means.
Okay, great. Yeah, thank you so much.
All right, good luck.
Yep, have a wonderful day. Bye-bye.
You too. Bye-bye.